So here's my Philips 212 turntable with 78 RPM modification. So I actually used to work for Philips in my last job, which is kind of cool. They were the company that bought out the old American companies, Magnavox, Philco, Sylvania. I've used this Philips turntable as my main stereo turntable and main quadraphonic turntable for several years now, and while I was doing research on it last year, I came upon a video by VWestlife of a turntable that was modified to have 78 RPM.
But the way you get 78 on this is this knob here. You pull it up when it's in 45 mode, and that switches it to 78 mode, as you can see by that turning yellow. And turning this is your pitch adjustment for 78.
And I thought I could do a bit better. So the turntable that VWestlife had, they drilled a hole right here and mounted a potentiometer and switch to control the 78 RPM function. When I modify devices, I like to make it possible to go back to factory specifications, and I strongly dislike the idea of drilling a hole in a nice original piece of equipment. So for mine, what I did is I made it so that when you select both 33 and 45, it will run at 78 RPM. So the reason I chose this Philips 212 is that it is a turntable designed to be suitable for CD4 quadraphonic LPs. For a phonograph to be suitable for CD4 quadraphonic discs, it needs to have low tone arm and output cable capacitance. Specifically, the total capacitance between the pickup cartridge and the input of the demodulator needs to be less than 100 picofarads. And this turntable does indeed conform to that specification. So I've got a JVC 4DD5 demodulator and a Audio-Technica Shibata pickup cartridge that has audio response out to, I believe it's 60 kilohertz. You need an extended ultrasonic frequency response cartridge in order to pick up the CD4 carrier signal. But that's not important right now. So watching VWestlife's video and reading through the comments, it was explained that basically to get 78 RPM on this turntable, you need to short out one of the resistors in the 45 RPM speed circuit, which was simple enough that it made me want to try the modification, and it made me want to put my own spin on it. I wanted to make my 78 RPM speed modification seem like something that Philips themselves would have done from the factory. So my modification was designed to kill two birds with one stone. The two things I disliked about this Philips since I put it into service are that it lacks 78 RPM capability, and that the factory control behavior is that if you were in 33 RPM mode and you wanted to go to 45 RPM mode, you couldn't just touch 45 RPM mode and go into it. You had to stop the machine completely and then go into 45 RPM mode. They designed the logic on these controls to lock you out of changing speeds while the player is running. On the way to implementing the 78 RPM speed, I actually was able to disable that annoying feature and make it so that I could jump from one to the other and vice versa, and one speed would cancel the other speed out. I had to go a step farther and disable the cancel so that I could enable both speeds at the same time to get 78 RPM. That's 78. If I hit stop, I can go directly to 45, and I can also jump directly to 78. Basically, the motor-controlled circuit on this turntable consists of 4 parts. A main power supply, a servo with feedback, and a logic control. The control logic is composed of 2 to 3 discrete transistor SR latches. In order to change the operating behavior, I just had to take resistors that would feed back signal from one latch to another and remove a few of those resistors in order to enable both speeds to be selected at the same time and to disable mutual canceling between the different speed operations. The outputs of those latches go to transistor switches that basically gate in or out the resistors that set the voltage constant that the servo compares against to set the speed. Now there are 4 pitch control potentiometers on this turntable. 2 of them are hidden underneath and are service adjustments, and 2 of them are accessible from the top as user adjustments. Basically how they are set up is you want to center the user adjustments at the center of their range and then adjust the service adjustments so that the turntable is running exactly on speed for 33 and 45 RPM. Once I modified the control logic so that it was capable of selecting 33 and 45 RPM at the same time, what I did is on the lines feeding out of the logic indicating 45 active and indicating 33 active, what I did is I took components known as either opto-isolators or optocouplers depending upon the application, and set them up so that the input LEDs of the optocouplers, one optocoupler's LED would turn on off the 45 and the other would turn on off the 33. The transistor halves of the optocouplers were wired in series and feed the coil of a relay. What the pitch control relay does is it disconnects the 33 RPM pitch resistors and it modifies the circuit of the 45 RPM. It bypasses a resistor that gives 45 RPM speed, and it switches the service adjustment pitch potentiometer under chassis, the hidden service adjustment pot, for a separate identical potentiometer that I use to set the 78 RPM speed. So how I've configured it is I set the 45 RPM user pitch control to center of rotation, set the 45 RPM hidden service adjustment so the turntable speed is dead accurate at 45 RPM. Then I switch the turntable to 78 RPM and take the additional potentiometer that's hidden inside the unit, adjust that for correct 78 RPM speed, and that makes it so that the pitch control for 45 and 78 should be at exact correct speed for both speeds at the center of its rotation. And in that way I've made it so that I have all the controls you would expect for this to operate in free speed mode without modifying any of the external components. So let's have a demonstration of this.
hotter than burning inside. I love you. No use to pretend. There, I've said it again. I've said it. What more can I say? Believe me, there's no other way. Get your kicks on Route 66.
Now you go through St. Louis and
And the auto stop caught it nicely. You've heard this played back on my homemade output transformerless vacuum tube amplifier. And a pair of Sansui Classique 1500 tower speakers, which I wish I could find another pair of. So there are a few things left to do on this to optimize it for 78 RPM. So I need to either find a 78 RPM stylus for these Audio-Technica cartridges, or get another one of these replaceable interchangeable cartridge sleds and get a 78 RPM optimized cartridge for this phonograph. These plastic sleds are ridiculously difficult to get a hold of. I haven't seen any come up for sale anywhere for a number of years, and I finally got this one by buying another Philips turntable that used the same cartridge sleds and stealing one out of that. One thing that would help to optimize this also for 78 RPM is to slide this tracking weight forward a couple of notches to get more than the bare minimum tracking force that these Audio-Technicas require for LPs. Rather than disturbing that setting, which is optimized for LPs, which is the majority of what this player runs, I'm probably going to, in practice, just stack a dime on top of the head shell to increase tracking force for 78 RPM applications. So there's a company called Rivermont that issues jazz on modern stereophonic vinyl 78 RPM records. I would have liked to have obtained a copy of one of their records and used as a demonstration of this turntable, but things didn't work out on that. I'll put a link to them in the description. So that concludes the tour and demonstration of the Philips 212 turntable that I've modified. So if you like this video, please like and subscribe. Let me know if you'd like to see a video documenting schematically the changes I've done to it and a tour of the innards. I can show you exactly what I did to get this to the state that it's at. Thanks for watching. So sometimes doing these videos help me to get my act together. Case in point, these old Taiwanese-made Radio Shack RCA Y splitters. These things are terrible. They almost always break off at the male end and basically go open circuit and you lose operation. Sometimes they'll look perfectly normal and they'll still be dead. One of these is dead. I think this is the last pair of these I have in any of my systems that haven't had the male end sheared off, and these are now going to be decommissioned. Note to self, never use these terrible adapters again. Use the better ones of the other styles that Radio Shack and other companies made. Rant over.